So the transformations that we've already learned about, we did it with 5 common functions, or 6 common functions in chapter 1. We talked about them with polynomials after that, which were more. And now we can do them with, we did them with exponentials last class. Now we can do them with logarithms. They always mean the same thing. It means subtracting 1 inside a function is which kind of a shift? Horizontal to the right. Inside the function is left or right. So that is right 1. Right. Okay. Now notice if the graph shifts to the right, then the asymptote has to shift to the right too. A horizontal shift will move a vertical asymptote 1 to the right. In fact, the x-intercept, which used to be at 1, 0, now it has to be at 2, 0 because it shifted 1 to the right. Everything on the graph goes 1 to the right. In this graph right here, what's the domain? This line right here. 1. It shifted 1 to the right. The domain was x greater than 0. Now it's x is greater than 1 because you shifted it 1 to the right. Okay. How about if you add 2 outside the logarithm? It's a vertical shift, plus means up, right? So that's up 2. Okay. What does that do to the asymptote? Nothing. You take a vertical line, you move it up or down, it doesn't change it. So what does it do to the domain? Stays the same. Okay. So when you're doing the problems, I think there's like 5 or 6 problems of basically matching graphs to functions. Okay. It's about understanding the transformations, right? Don't get so hung up with, okay, I'm just going to put in the calculator and see which one of those matches that one. That is an example of what I was saying last class about not really trying to understand the thing, just trying to get by with finding the answer, right? We have done these transformations now for many different kinds of functions, and that's what we're supposed to be focusing on, not just can I enter it in the calculator and then recognize it on the graph. That's missing a piece of understanding there.